So in this video we are going to talk about one of the very famous problem of the static equilibrium, which is based on the balancing of torque, and the problem is identified as the ladder on the corner. So the question says that a ladder of mass m so the question says that a ladder of mass m and length l leans against the frictionless wall with the quarter of its length lying hanging over the corner. Assuming that there is a sufficient friction at the corner to keep the ladder at rest, what is the total force the corner exerts on the ladder? Okay, so first thing first, let us draw the free body diagram of the problem. So for that, let's draw the free body diagram of it. So there is a ladder which is leaning against a frictionless wall such that a quarter of its length is lying outside the surface. So this is basically so yeah. So anyway, now let's label this length is actually L by 4. Okay, so and this is the point of contact from the surface, and this is against this, and this point is the point of contact with the wall. Okay, so this is the point of contact with the surface and this against the wall, right? So this is mu is equal to 0 frictionless because this is frictionless wall. But there is a finite friction on the surface, as a result of which the ladder is resting on the surface against the wall at an angle theta with the horizon. Okay, so obviously there will be a force of gravity acting downwards, which will be the mass times g, right? So first thing first, one of the very important thing is we define our coordinate, based on which we will be doing our calculation. So depending on the system, for the simplicity, let's call this as our convention of the axis, call this as I cap direction, call this as j cap direction, right? So this side is positive and this is positive j cap direction. So now we take the components of the forces. So yeah, so and from this and from this end, obviously there will be a normal force acting, normal force for the wall. W subscript is for wall, and from the corner there will be normal force, and S means for the surface, and the friction force which will be acting upward, right? No, sorry. So normal force will be always be perpendicular to the surface, to the point of contact, right? So this will be NS and this will be FS. Okay, so that's it. That is all about the forces. So let's break the forces into components, because that is the easiest, and that is how we do the problem. All right, so and let's sum it all the possible all the forces into components. Let's break all the forces into components. So in I cap direction, what forces are acting, like based on the axis that we have defined, it is Fs, and this is minus of mg sine theta, right? And the other force is minus nw, if this is theta, so this is also theta, so n with minus sign, nw cos theta, right? And the j cap, all the forces that is acting is minus of mg cos theta along with ns, and is there some other forces acting, yeah. So nw, and then the other component is nw sine theta, right? Because it will have the component form like this, right? So yeah, so this will be in this direction, in this direction it will be nw cos theta, and in this direction it will be nw sin theta. All right. So now let's since the ladder is in the static position, so the summation of all the forces along I cap, sum is equal to 0, which is equal to summation of all the forces along j cap fj hat, right? So summing up all the forces along the I hat, so summation of I f I hat, which is equal to, it can be seen from this equation, which is fs minus mg sin theta minus nw cos theta is equal to 0, or fs is equal to mg sin theta plus nw cos theta. Okay, call this as equation A, right? And so likewise what we do is we identify all the forces along the j component, along the j hat, and then we will sum it up and equate it to 0, right? So this could be given as ns minus mg cos theta plus nw sin theta is equal to 0, or ns is equal to mg cos theta minus nw sin theta, right? So here are two equations. Just look that there are basically three unknown variables, which is fs, the other one is nw, the other one is ns, and there are just two equations like a and b. So there must be some other equation. Three unknowns requires three equations to and we will solve those three equations to identify these three unknown variables. So the other equation can be figured out by balancing the moment. Okay, balancing the moment of force. Balancing the moment of force. These two are that we have balanced the force, and now what we do is we balance the moment of the force. The moment of the force, this is basically the torque, which is given as r cross f, which is rf sin theta, right? So we are okay. So now balancing the torque, balancing the moment of the torque could be done along any point that we have choose, for the sake of convenience. So what we do is let's choose this point and call it as O. Okay, so now what we do is, let's say let us balance the moment about the point O. Okay, now why we are choosing the point O? Because if we choose this, so this ns and fs will have zero component, because these forces are already passing through this point itself. So we need not to think much about it. We just the moment of these two forces will be already zero. So all will be left is the moment of this mg, which will be balanced by this moment by nw, right? So the moment of mg, so this is L by 4, this distance is L by 4, right? So and again, so this distance is again L by 4, because the mg, it acts downwards from the center of the ladder if in case it has the uniform mass density, which is so in this question, right? So and this mg will have this component as mg cos theta, which is, so mg cos theta, if this from this distance it has L by 4, so the moment is mg cos theta L by 4. It will be balanced by like again this nw against this nw cos theta will have zero moment, because theta is 0 if we are choosing this as the axis of force, right? So all we will have this nw sin theta, it will have the component, it will have the moment about the point O. So and the length, this length is 3 by 4, right? So this length is 3L by 4, right? So and the perpendicular distance NW sine theta 3L by 4, right? So NW sine theta 3L by 4. So L by 4 goes out, L by 4 goes out. So we got mg by 3 cos theta is equal to NW sine theta, right? So now we already have these three equations, equation A, B and equation C. We call this as equation number C. Let's call it as equation number C. A, B and C. This is the B, right? And call this as A. We have labeled this as A. So now we have three equations and three unknown. So that will be identified with the help of these three equations. So now what we will do is we will use equation number C. Using equation C, and equation NW sine theta, and equation B we get NS is equal to mg cos theta, mg cos theta minus NW sine theta, where NW sine theta is minus mg by 3 cos theta. This comes out to be 2 by 3 mg cos theta. So this is the value, this is the form, this is the value of the NS. Okay, so let's put it in the square box so that it can be easily identified later when we are looking for it. Let's call this equation as D. Okay, so now we have NS. So once we got NS, so we can have, what we can have is so Fs can be identified. So Fs is mg sin theta. Now Fs is what? Mg sin theta plus Nw cos theta. Mg sin theta plus Mw cos theta. Nw, let's call it Nw cos theta, right? So now what we do is we know this its value, so we will just put it here. So Nw sin theta is mg cos theta by 3, and this is again cos theta by sin theta. This is Fs. This is equal to mg sin theta plus mg cos square theta by 3 sin theta. Okay, so again it will be again simplifying this, we get 3 mg sin square theta mg cos square theta by 3 sin theta. All right, so it will be 2 mg sin square theta plus mg, right, by 3 sin theta, right? Am I missing something? I think no. So we have identified this, the form of Fs as well. So now for the static equilibrium, we know that for the static equilibrium we know that Fs is always less than equal to mu time Ns, right? So Fs, we know its value. Let's call it as equation number E. So Fs, that means 2 mg sine square theta plus mg by 3 sin theta will be less than equal to nu time, and ns will be 2 by 3 mg cos theta. Okay, that means mu will be always greater than equal to, this 3 goes out with this, this is 2 mg sine square theta plus mg by 2 mg cos theta. All right, I think am I missing something? No? Yeah, I think, yeah, we can cancel out this, or mu greater than equal to mg, you know, just cancel out the mg from the numerator as well as the denominator, then we will get 2 sine square theta plus 1 by 2 cos theta. All right, okay, and I think sine theta remains, right? So it will be sine theta. So or mu greater than equal to 2 sine square theta plus 1 by, this is sine 2 theta, right? So this is the thing. So now now if we minimizing this mu against the theta, so d mu by theta is equal to 0 gives us theta is equal to pi by 6. Try it by your own. It's just simple. All you have to do is just take the derivative of it and then equate it to 0, and then by using some basic trigonometric identities you will land up to the equation theta is equal to pi by 6. So once you got the theta is equal to pi by 6, and then substituting this theta value back in this equation, will lands up to the thing that mu is equal to root 3. Mu minimum is being given is root 3. Therefore, like you can see now, what you can see from the from this diagram is the force on the ladder by the corner is basically two forces, ns and fs, right? Those are perpendicular in direction. So the net force exerted by the corner on the ladder is a resultant of this force and of these two forces, ns and fs. So now the force exerted by the corner on the ladder is resultant of ns square plus fs square. Okay, and ns is equal to, ns is what we have figured out, 2 mg sine square theta plus mg by 3 sin theta. So from equation 2 mg sine square theta plus mg by ns is this one, ns is 2 by 3 mg cos theta. For theta is equal to pi by 6, 30 root 3 by 2, 2 by 3 mg, this is basically root 3 by 2, so this is mg by root 3, right? So this is fs is equal to ns is equal to mg by root 3. Similarly, we calculate fs by substituting this value in fs is equal to, fs can be calculated as Fs is comes out to be mg for theta is equal to pi by 6 in equation number E, right? So Fs comes out to be this. So that total force, total force is given as root under mg square plus mg by root 3 square. Okay, so it will be m square g square by 3. So this will be mg 1 plus 1 by 3, 4 by 3. It will be just as this. This is the total force acting on the corner. Total force acting on the ladder at the corner.